Now, I want to talk about absolute extrema. Going back to my example in 2 dimensions, if I was to say I have the following graph. Then calculus could figure this point out. That's where the derivative equals 0. That would be a minimum or a maximum. That's a local. If you don't include the endpoints, it doesn't make sense to talk about absolute, because there's only one point, and obviously that's the absolute minimum. Now, if I take the same graph and I limit that graph, if I limit it between A and B, keep in mind how this works. I'll find f of A, I'll find f of B, but this point right here, say at L, I need calculus to figure out f of L. And I'll look at those 3 points. The highest of them is the absolute maximum, and the lowest of them is the absolute minimum. Now we're talking about 3 dimensions. How does that correlate to 3 dimensions? Well, the same deal, except we're going to have a region, not an interval. An interval is a piece of line in 2 dimensions. In 3 dimensions, it's a piece of a plane. So, find the absolute extrema values and the saddle points of the following, if there is any. There's an equation. D is closed over a region. Now, I need that region. I need to look at that region. This is what you're looking at on the floor. I'm looking at 0, 0, 0, 3, and 4, 0. So, I'm looking over this triangle. Even though I'm not sketching the graph of this, I don't need to graph it. I will graph it for you and show you how that works. And this is how it works. I have to look at along this path, along this path, and along this path. That's taking the place of figuring out A and B. But inside of this region, I need calculus to figure out if there's a maximum or a minimum. How do I do that? I take f sub x to figure out the critical numbers. F sub x is 1 minus y. F sub x, x is a 0. F sub y is 1 minus x. F sub y, y is also a 0. And f sub x, y is a negative 1. So I'm already aware that if I take D, which is f sub x, x, times f sub y, y, minus a negative 1 squared, that's negative. So I know inside of this region, D, there's really not much, nothing's going on. But the work really comes at those 3 values. At this point here, do you see that at this line, anywhere along this line, along C1, do you agree that x is always 0 and y varies between 0 and 3? Well, take the function f, and now what you're doing, you're mapping the 3 dimensions to 2 dimensions in this case. What is f of 0y? F of 0y is 0 plus y minus 0 times y, which is 0. F of 0y, the function along this, behaves like a straight line. If y is running between 0 and 3, I don't need calculus for that. I know that if this is running up and down, then y equals 0 and y equals 3 would be an actual maximum or minimums. So I know f of 0, 0 is actually 0. And f of 0, 3 would be a 3. Now I have 2 values to put on the side and wait and see if there's something higher or something lower. if I go along with this path, those are the easiest two paths. Along C2, what I noticed that y equals 0 and x varies between 0 and 4. So if I find f of leave x, because it's varying, and let y equal 0, that's going to be x plus 0 minus 0. F of x 0 is actually x. Y equal x, I know how that works. That's a line. If you cut it off at 0, 0, I already got that point. I don't need to find it again. But f of 4, 0 is another point at this end point, at this point, and at that point. It seems something's going on. That is 4 plus 0. That's just 4. Now comes the tricky part. The tricky part is really along C3. Along C3, this is y equal 1, 2, 3, and the slope of the line is negative 3 over 4x. Y equal negative 3 over 4x plus 3. So what I do, I eliminate the two dimensions. I'll say that's x, and in place of y, let me use negative 3 over 4x plus 3. What that does, that makes the equation in terms of one unknown, and I know how to do calculus in terms of one unknown. That is x, I leave alone, plus y is 3/4 x plus 3, minus x times y, negative 3/4 x plus 3. F will equal, and let's see how this works, x minus 3/4 x plus 3 plus 3x squared over 4 minus 3x. So altogether, I'm looking at a function that has 3 over 4x squared. Negative 3 plus 1 is negative 2. Negative 2 minus 3 over 4. What is that? 8. That's negative 11 over 4x plus 3. That's the equation I'm trying to find a maximum or a minimum on. This work I already did. I'm going to do this work right here. Let me get a bit more space and show how this works. So, since this is f, and I got it already, let me shift that to the left. Do I know how to take a derivative in terms of one unknown? Yes, I do. I take a derivative of that. And that is 3/2 x minus 11/4, and I set it equal to 0. Since it's in terms of one unknown, I am aware how to find the critical, not point, the critical value. So if I set that equal to 0, clear the fractions, multiply by 2, 6x minus 11 equals 0, x equal 11 over 6. So if x equal 11 over 6, what does y equal? It's right there. Y would equal negative 3 over 4 times 11 over 6 plus 3. Numbers don't work out as nicely as you like. So that would be negative 11 over 8 plus 3, all over 8. 24 minus 11 is 13. Hopefully I didn't make a mistake. And if I did, you understand the idea. So I have 1, 2, 3 values. I need to know what is f of 11 over 6, 13 over 8 equals. And there's y. That is 11 over 6 plus 13 over 8 minus the product of those. And that would be 11 over 6 plus 13 over 8 minus 13 times 11. (143 over 48). So if I go all over 48, 8 times, that's 88. 6 times 3 is 18. 678 minus 143. What would that be? I'm really bad with math. 88 and 78. Of course, you could use a calculator. 166 minus 143 is at 23 over 48. That's the last value I have to find. So the 4 values, really 3 values that I need. I have z equals 0, z equals 3, z equals 4, and 23 over 48 is a number between 0 and 1. So I say the absolute maximum is f of 40, which is 4. And the absolute minimum is f of 00, which is 0. Now I'm going to take that and look at what that looked like, and I'll come back in a minute. Let me elaborate on what that means. I did sketch the graph. The graph is the blue. Do you see the black triangle right there? If I look at the triangle, do you see the triangle is going to cut all the way? So when I take that piece of that, this point, this is like a laser triangle that's going to cut straight up. This point right there was one critical point. This is going to run up. This is going to run up all the way. Let's see, can I do that? No, it doesn't like that. Okay. This is going to run up all the way to the curve touching right there. That turns out to be the maximum, absolute maximum. And this point right here is going to run up as well. And it turns out the point 40 for x equals 0, y for x equals 0, y equals 4, and z equals 4 is the highest of all of those. Again, you don't need the 3D. This is a problem as well, a bit tougher than that, but easier to see, I think. I might have to change the domain. I made those at random. Let's see how this works. If I take f sub x, isn't f sub x negative the sine of x cosine of y? F sub y, isn't f sub y negative the cosine of x sine of y? I'll deal with that in a minute. What is f sub xx? F sub xx happens to be a negative cosine of x cosine of y. And what is f sub xy? F sub xy is going to be a positive sine of x sine of y. And f sub yy is going to be a negative cosine of x cosine of y. Alright, so these values I need to figure out the maximum and the minimum, figure out d. For now, let me go over and figure out this system. F sub x, which is negative sine of x cosine of y equals 0, and negative the cosine of x sine of y equals 0. This means sine of x equals 0 or cosine of y equals 0. If sine of x equals 0, I'm getting x to be where does sine equals 0? At 0 or pi. 0 or pi. Do you see that there's no need to worry about pi because it's not included? So 0 is the one point that I really want. X equals 0. Now if I put x equals 0 in there, remember this is a system. This point, if I put it in there, doesn't that mean that negative the sine of y equals 0? Where does sine equals 0? Sine equals 0 when x equals 0. So I get a point. And the reason I'm not worried about pi because it's not even included. Now, the second point, how about cosine of y equals 0? Cosine of pi equals 0, so this is x equals 0 or pi. Here, y equal pi over 2 or 3 pi over 2, but I'm only allowed to go between negative pi. Oh, I see. Yeah. Pi over 2 or negative pi over 2. Right? Cosine is 0 here and here. And I'm running between negative pi to positive pi. And sine is 0 between 0, let me see. Sine is 0 right here or right here. This is the only point that's allowed. So here I get 2 points. if I let y equal pi over 2 and I throw that in here, wouldn't that mean negative cosine of x? So for this point, negative cosine of x equals 0. Where does cosine equal 0? We already agreed at pi over 2, or at negative pi over 2. So I'm getting 2 points right there. And if I let y equal negative pi over 2, put a negative pi over 2 in there, that will be a negative 1. So that's where the cosine of x equals 0. That's also as plus or minus pi over 2. So I have the origin and those 4 points to worry about. I am going to bring the graph into this to show you what we're doing. So this is over this whole rectangular piece. Let me graph it and bring it in and talk about it. I got the graph. The graph looks like that, like a bunch of waves. And, okay, what is that? And if I look at, this is the x, this is the y. Remember, I ran this from x being between negative pi, negative 3.14. I can barely read those. So 3.14 is right there. And negative 3.14 is right there. And y being between 3.14 and negative 3.14. We're talking about this region. And do you notice what's happening? I got 0, 0. Do you see 0, 0? I got pi over 2 for x, positive, and pi over 2 for y. Right? Oops. Right there. And I got negative pi over 2 for x, pi over 2 for y. That's right there. And positive pi over 2 for x, negative, that would be this point down here. And in the back, but it's hard to see, it's down there, there is a minimum as well, it seems. Now, you don't need the graph. All what you need is figure out, I have 5 critical numbers. Figure out D. D is, well, actually, figure out f of 0, 0. Figure out f of pi over 2, pi over 2. F of negative pi over 2, pi over 2. F of pi over 2, negative pi over 2. And lastly, figure out f of negative pi over 2, negative pi over 2, negative pi over 2. So this is positive pi over 2, pi over 2, negative, that's those two. And positive and negative, and this is always negative, that's those two. Well, it's right there. The work is a bit intense, but here. If I put 0, 0 in, isn't cosine of 0, 1, sine of 0, 1? That's a 1. How about if I put pi over 2? Isn't that a 0? That's a 0, that's a 0, and that's a 0. So what does that tell me? That tells me we have an absolute maximum and we have an absolute minimum at 0. So probably the cutoff, this point probably was right there when we cut it. Again, I could figure that out exactly where it is on the graph, but that's how this works. Now, the next problem up, I modified that slightly. We're looking over a region. The region is x is positive, y is positive, and we're looking at inside of this circle. So if I go 2 units above, 2 units below, we're talking about this circle, this piece of the circle. C1, C2, C3. Well, first, f sub x is 2xy squared. F sub xx is 2y squared. F sub xy is 4xy. Very good. F sub y is 2x squared y, and f sub y is 2x squared. Got it. I need those for my d if there is a need. But here I'm looking for absolute, so it doesn't matter. What are the critical values? So in this case, I was seeing if there's something inside. If it's a saddle, I don't have to worry about it. Here, I do have to worry about it a bit. Well, let's see how this works. Where is f sub x equals 0? So again, on this problem right here, I didn't worry much about those because they told me there's a saddle in the middle or inside of the region. I don't have to worry about it. Here, it gave me values, right? And I figured them out because I'm going to find all the y values anyways. So we need to test if it's maximum or minimum. So here, f sub x equal 0. Well, what's f sub x? F sub x is 2xy squared equals 0. Keep in mind this has two values that I have to worry about. This says x equals 0 or y equals 0. So I need to figure out what happens with those are separate points. F sub y equals 0. There's f sub y. That is when 2x squared y equals 0. Well, if x equals 0 and I put it in there, that's going to work to be 0 and that's going to work to be 0. I'm only getting the origin. Right? So I'm not getting much out of that. I'm getting just 1 point. Okay, no need to test it. It's only 1 point. And I know already f of 0, 0 is 0. So I have 1 point so far that I could look at. Now comes the busy work. Along C1, this is 2. Along C1, this path, x equals 0, but y varies between 0 and 2. So if I replace x by 0, y by, just leave it alone, I'll get a 0. For any value of x, of y, this value is going to be 0. I already have that. Not that bad. I chose it to work nicely. If I take along this path, along C2, I notice that y equals 0 and x varies between 0 and 2. So f of x0, if you put a 0 in for y, that's also 0. No need to worry about that. That's one value I have so far. I don't know if it's a minimum or a maximum, depending of this gives any value. Isn't this saying y equal the square root of 4 minus x squared? So if I proceed and say, let's find f of x, and in place of y, square root of 4 minus x squared, I'll get f to equal, x you leave alone, you square the y, wouldn't that make it 4 minus x squared? So f will equal negative x to the fourth plus 4x squared. Now, this is in terms of one unknown. And what I'm going to do, I'm going to take a derivative of that. I'll take a derivative of f. That is negative 4x cubed plus 4x plus 8x equal to 0. Factor a negative 4x out. You will have x squared minus 2. So I have x equals 0, x equal plus or minus radical 2. Radical 2 is accepted. Radical 2 is somewhere in there. So I have f, if x equals 0, y would equal what? Remember, there's y. Y would equal 2. I got this point. I got to figure out what that is. F, if x equal radical 2, well, y equals the square root of 4 minus x squared. If I let x equal radical 2, isn't that a 2? Doesn't that mean that y will equal a radical 2 as well? Need to figure that out. And if x equal negative radical 2, well, negative radical 2 is outside of the region, and I don't have to worry about it. So I have two more values to really worry about. What is f of 0, 2? That's 0 squared, that's also 0. And what's f of radical 2, radical 2? That is radical 2 squared times radical 2 squared, which is a 4. So I have these three values to worry about. One of them is right there at this point. One of them is 0, 2. And one of them is at radical 2, radical 2. And if I go ahead and figure out, this will be the absolute max, and those two will be the absolute minimum. And if I look at the graph of this, I already graphed it. Remember, this is how it looks like. Look at the top and the bottom. But if I take a circle, let me see if I could sketch a graph. Let me put it up just a bit. And let me see if I could fit it here. If I take the region x equals 0, y equals 0, and I look at a piece of the graph that's running up to the curve, it turns out at radical 2, radical 2, again, this is like a laser cutting straight up. It's going to touch at the origin. Here it's going to be still at zeros, but this point right here is going to trace along the curve and come back down, and that would be a maximum on this region. So above this graph, it seems the curve is flat, but it's coming up above on the 3 dimensions. When this picks up and figure that out, that will be an absolute maximum. And we could talk about this tomorrow in class if you like, or the next class meeting. One more to go, and this is a simple problem. This says, find 3 positive numbers whose sum is 8. And whose squares are as small as possible. And the sum of whose squares, x squared plus y squared plus z squared, is the sum. I want that to be as small as possible. So what I'm really looking at, this is z equal 8 minus x minus y. If I take this and I substitute that right there, I'm looking to maximize this function s, which is x squared plus y squared plus 8 minus x minus y squared. I want to minimize or maximize that. Well, I'll take s sub x, that's 2x plus 2 into 8 minus x minus y, times a negative 1. I'll take s sub xx, that is 2 minus 2 times a negative 1. So I get that to be a 4. Very good. I'll take s, and I need s sub xy. S sub xy will be a 0. That will be a negative 2 times a negative 1, because that's a negative. So that will be a positive 2. Now if I find s sub y, that is 2y plus 2 into 8 minus x minus y times a negative 1. And if I find s sub y, that is a 2, this is going to give me a negative 2, and the derivative of that is a negative 1, that's going to be a 4. So far, it looks okay, because I'm getting d to equal f sub xx, or s sub xx, that's 4, s sub y, that's a 4, minus s sub xy squared. I'm getting that to be 16 minus 4, 12, which is bigger than 0. That's good news. And s sub xx is positive. So I have a minimum, but I need to know where that minimum is. How am I going to figure that out? Well, that's the bulk of the problem. That is, where does that and that equal to 0. And that's how we're going to do this. We're going to say we have 2x minus 16 plus 2x plus 2y equals 0. That's the first equation. The second equation, we're going to get 2y minus 16 plus 2x plus 2y equals 0. This is a system of equations. Or I could say that is when 4x plus 2y equals 16, which means 2x plus y equals 16. The bottom one is going to be 2x plus 4y equals 16, or x plus 2y equals 16. If I multiply the top equation by a negative 2, that would become a negative 4x and negative 2y equal negative 32. And if I add those, the y's cancel out. I'm left with negative 3x equal negative 16. Is that right? Yeah. So x will equal 16 over 3. Once I get x, I'll go for y. Let's go for this one. 16 over 3 plus 2y equals 16. Clear the fractions. Subtract 16 from both sides. That is 32. And y would equal 32 divided by 16, by 6. And that would be 16 over 3. And can I find z? Yeah, z is right there. I could say z is 8 minus 16 over 3 minus 16 over 3. Z is all over 3. That is 24 minus 32. Z will equal a negative 8 over 3. Okay, I found a mistake, a quick mistake. I was thinking that can't be negative, something's not right. So here it is. I'll fix it really quick. Just a couple of minutes. Sorry about that. The mistake was when I divided by 2. If you divide those by 2, isn't that an 8? And that's an 8. And when I multiply this by a negative, that becomes negative 4x minus 2y equal negative 16. Much better. Negative 3x will equal negative 8. So x equal 8 thirds. If I take this equation and have 8 thirds plus 2y equal 8, or 8 plus 6y equal 24, 6y equals 16, so y is 16 over 3, which is 8 thirds. Much better. I was worried. Now if I take this, I'll say z equal 8 minus 8 thirds minus 8 thirds. Z will equal all over 3, 24 minus 8, and 8 is 16. I'll get z to be 8 over 3. And this problem is for the next section. Now, even though the section is going to be long, I promise you the next section is going to be very short. So I'll make it up to you. I'm sorry about this being this long. I wasn't intending that way, but that's what it is. Right? And that concludes this section.